Pressed onto clay, cuneiform tablets are incredibly durable. They're literally fireproof. But for thousands of years, no one was able to translate them.
A machine just did something scholars once thought would take lifetimes. It began translating ancient cuneiform at remarkable speed. According to research published in PNAS Nexus, that breakthrough is real. The claim that it uncovered shocking truths about human races is another story entirely. Somewhere inside one of history's largest tablet archives, preserved through projects like the Cuneiform Digital Library Initiative, the evidence still waits. So what did AI actually read, and where does certainty begin to break? The real breakthrough. The story becomes much more impressive once you strip away the viral headlines. Researchers weren't trying to build a machine that could reveal hidden truths about humanity. They were trying to solve a practical problem that has challenged Assyriologists for generations. There are simply too many ancient texts for any group of scholars to translate quickly enough using traditional methods alone. Back in 2023, something happened that caught the attention of archaeologists far beyond the AI world. A research team behind a study published in PNAS Nexus trained a machine to work through Akkadian cuneiform, one of the oldest written languages ever deciphered. Instead of trying to replace experts, the system studied thousands of tablet translations that scholars had already completed. Over time, it learned the patterns well enough to produce its own first-pass translations. They weren't perfect, and the researchers never claimed they were. The goal was much simpler: give specialists a reliable draft so they could spend less time starting from scratch and more time solving the difficult parts that still demand human judgment. The researchers measured its performance using standard translation benchmarks, showing that the system could provide results accurate enough to become a useful starting point for specialists rather than replacing them. That distinction matters more than it might seem. According to the PNAS Nexus study, the system wasn't taught Akkadian by textbook. Rather, it was learned by analyzing thousands of cuneiform texts, already translated by specialists over decades. As it saw more examples, it began recognizing patterns in words, grammar, and translation structure, allowing it to suggest likely English renderings even for passages it had never encountered. Despite these advances, the researchers reiterated that these were working drafts, requiring expert review to check every result against the original signs, language, culture, and historical context. Think about what the researchers were actually facing. Ancient Mesopotamia left behind an enormous written legacy pressed into clay. According to the Cuneiform Digital Library Initiative, hundreds of thousands of cuneiform tablets and fragments have been documented from museums, excavation sites, and private collections around the world. They preserve everything from royal decrees and business accounts to letters, medical recipes, astronomical observations, legal disputes, and epic literature. Many have been photographed and catalogued. Far fewer have received complete scholarly translations. That vast archive is challenging to comprehend. According to the Cuneiform Digital Library Initiative, these tablets constitute thousands of years of daily life and state records, not a single continuous story. One might document grain deliveries to a temple, another, a neighborly legal dispute, others, diplomatic letters, astronomical records, hymns, royal inscriptions, or literature. Each new translation adds another piece to the still-growing historical record. Working with that material has never been as simple as reading a complete page. Many tablets are cracked, weathered, or survive only as broken fragments with entire lines missing. A single damaged sign can change the meaning of a sentence, forcing scholars to compare it with similar texts before deciding which reading fits best. According to the Max Planck Institute's work supporting the Cuneiform Digital Library Initiative, decades of digitization have transformed that process by bringing photographs, catalog records, transliterations, and earlier scholarship into searchable digital collections. Researchers can now compare tablets from different museums in minutes instead of spending months tracking them down individually. Artificial intelligence builds on that foundation by helping scholars move through this enormous archive more efficiently, making the first stage of translation dramatically faster, without replacing the careful human judgment that gives those translations their historical value. Here's where the scale becomes almost difficult to imagine. Every damaged tablet introduces missing words. Every regional variation can change the meaning. Many inscriptions survive only as broken fragments scattered across different collections. According to the Max Planck Institute's work supporting the Cuneiform Digital Library Initiative, decades of digitization have made these records increasingly accessible, creating the possibility of combining traditional philology with modern computational analysis. Instead of replacing scholars, digital tools allow them to search, compare, and organize material that once required years of manual effort. That's the real breakthrough. Rather than unlocking one mysterious artifact, artificial intelligence helps scholars work across an archive so vast that no individual could realistically master it alone. According to reporting by Tech Explore on the PNAS Nexus research, the translation model is especially valuable because it speeds up the earliest stage of analysis. A researcher can begin with a machine-generated draft, identify likely readings, and then apply expert knowledge to correct errors, resolve ambiguities, and interpret difficult passages. Notice what the process still depends on. The computer recognizes linguistic patterns. It does not determine archaeological context. It cannot verify where a tablet was discovered, whether an inscription is incomplete, or how one fragment relates to another. Those questions still require excavation records, historical comparison, and specialists who understand both the language and the civilization that produced it. That's why the archive itself is really the heart of this story. The larger and better documented the collection becomes, the more useful AI can be. But usefulness is not the same as certainty, and a draft translation is not the same as a historical conclusion. So with this in mind, if the research is methodical and aims to assist the scholars, how does a translation tool become cited as proof of dramatic claims about human origins and lost secrets? When the research became a viral story. The story takes a surprising turn the moment it leaves the research paper. Inside the study, you find careful language, measured conclusions, and repeated reminders that machine translation is meant to assist experts. Outside that world, the same breakthrough suddenly becomes something much bigger. Videos begin talking about hidden knowledge, engineered humans, and long-buried truths that history supposedly kept secret. The technology hasn't changed. The storytelling has. This divergence is easy to understand. While scientific papers value precision, online platforms reward certainty, often at the expense of nuance. The PNAS Nexus researchers emphasized that their model produces drafts needing human scrutiny. They never claimed it settles historical debates. Instead, much of their work discussed limitations, such as data quality, translation length, and the enduring need for expert review before any results are trusted. The contrast becomes even clearer when you read the paper itself. According to the PNAS Nexus study, the researchers consistently described the system in careful, measured language. They discussed evaluation scores, acknowledged the model's weaknesses, and repeatedly emphasized that its output should be reviewed by specialists before drawing historical conclusions. The model was presented as a draft tool, not a final authority on the ancient world. Yet many online summaries quietly skip over those cautions. Instead of talking about translation quality or expert review, they jump straight to claims that artificial intelligence has uncovered forbidden knowledge, rewritten human origins, or exposed secrets hidden for thousands of years. Nothing in the underlying research makes that leap. It's easy to understand why the two versions spread so differently. Academic papers are written to reduce uncertainty wherever possible. Online storytelling often rewards the opposite. The faster a headline creates surprise, certainty, or emotional impact, the more likely people are to click, watch, and share it. That doesn't mean every creator is deliberately exaggerating the research. Sometimes each retelling simply becomes a little more confident than the last, until a cautious scientific result starts sounding like an unquestionable historical revelation. By the time the story reaches millions of viewers, the distance between the original paper and the popular narrative can be much larger than most people realize. According to Archaeology magazine's coverage of the project, researchers described artificial intelligence as a practical tool for helping scholars process large collections of cuneiform texts more efficiently. That's already an extraordinary achievement. Nobody needed to invent alien civilizations or hidden human races to make the research interesting. The scale of the archive is remarkable on its own. Language specialists have been making a similar point. According to Language Log, the system should be understood as a translation aid, not an independent authority on the ancient world. A computer can suggest readings based on patterns it has learned. It cannot explain why a king chose certain words, whether a damaged sign changes the meaning of an entire sentence, or how one fragment relates to another found hundreds of miles away. That's where the story quietly splits into two different versions. One version follows the sources wherever they lead, even if the answers remain uncertain. The other begins with a dramatic conclusion and works backward until it finds something that appears to support it. Ancient history is full of gaps, and those gaps make it surprisingly easy to build stories that sound convincing while drifting away from the evidence that inspired them. Think about that for a second. When you hear an astonishing claim about an ancient civilization, are you hearing what the original research actually concluded, or the version that became more dramatic with every retelling? That single question can completely change how you read a headline. The louder a claim becomes, the more carefully it deserves to be checked against the source that supposedly supports it. And that brings us to the next step in this investigation. If the internet's version keeps growing more dramatic, maybe the only way to understand what happened is to leave the headlines behind and examine the tablets themselves. What do the preserved records actually contain? Why AI still needs human eyes? The real surprise isn't that artificial intelligence can translate ancient tablets, it's that it knows when it starts running out of certainty. That's a detail that rarely makes it into viral videos, even though it sits right at the heart of the research. Back in the PNAS Nexus study, the researchers weren't trying to prove their system was flawless. They were trying to find out where it genuinely helped and where it still struggled. According to the paper, the translation model performed best on short and medium-length passages, producing drafts that were often accurate enough for scholars to build on. But as the texts became longer or more complicated, the task became much harder. Context stretches across multiple lines, damaged sections interrupt the flow, and one small mistake near the beginning can ripple through. And if the machine is only one part of a much larger process, what does that reveal about the viral claim that it uncovered a hidden truth about humanity in the first place? Everything that follows. A model might correctly translate most of a passage while quietly losing an important connection several lines earlier, changing the overall meaning without making the mistake obvious to someone reading only the English version. That's exactly the kind of problem human experts have spent years learning to solve. Imagine reading a book where every third sentence has been erased. You could probably guess parts of the story, especially if you've read similar books before, but every guess would depend on context. Miss one important clue, and suddenly the entire chapter means something different. Ancient cuneiform works much the same way. Many tablets reached modern museums, with cracked surfaces, worn edges, or entire sections missing. A single broken sign can leave more than one possible reading, and scholars often compare similar texts before deciding which interpretation best fits the evidence. Collections such as the electronic text corpus of Sumerian literature preserve multiple versions of important works because comparing copies is often the only way to reconstruct damaged passages with confidence. That's what makes this technology both impressive and limited at the same time. According to reporting by Tech Explore on the research, the goal wasn't to produce finished translations ready for publication. The system was designed to generate a strong first draft that scholars could inspect, compare with the original signs, and improve. That approach saves an enormous amount of time because researchers no longer have to begin every translation with a completely blank page. Instead, they can focus their attention where it matters most, correcting difficult readings, resolving ambiguities, and testing alternative interpretations. Language experts have highlighted the same point. According to Language Log, machine translation becomes genuinely valuable when people treat it as an assistant rather than an authority. A computer is exceptionally good at recognizing patterns across huge collections of text. What it cannot do is weigh archaeological context, evaluate competing historical explanations, or recognize when a rare expression carries cultural meaning that doesn't translate neatly into modern English. Here's where things become surprisingly easy to misunderstand. If the machine produces a sentence that reads smoothly, most people naturally assume it's correct. We tend to confuse confidence with accuracy because polished language feels trustworthy. Yet a fluent English sentence can still be historically wrong if a damaged sign was interpreted differently, if the original tablet belongs to another period, or if a technical term carried a meaning that changed over centuries. Ancient languages rarely offer simple one-to-one answers. That's why archaeologists, linguists, and museum records remain essential. According to the British Museum's collection records, tablets are studied alongside excavation histories, catalogue information, and related fragments that help establish where they came from and how they fit into the wider historical picture. A translation alone cannot provide that context. Understanding an ancient text means combining the words with the object itself, the place it was discovered, and the scholarship built around it over decades. That's why the biggest lesson from this research isn't that AI solved the ancient world. It's that AI made the first step dramatically faster while leaving the hardest questions exactly where they have always been, in the hands of historians, linguists, and archaeologists. And if the machine is only one part of a much larger process, why does the public version of the story keep presenting it as the complete answer to humanity's oldest questions? The truth hidden in plain sight. The investigation ends somewhere very different from where the headlines begin. We started with a bold claim that artificial intelligence had decoded ancient Sumerian tablets and uncovered shocking truths about human races. What we actually found was something quieter, but in many ways far more remarkable. The breakthrough was real. The extraordinary conclusion attached to it was not. Here's the thing. None of that makes the research less exciting. According to the PNAS Nexus study, artificial intelligence reached a milestone that scholars had been working toward for years. A machine can now assist with translating Akkadian cuneiform, helping researchers move through vast collections of ancient texts much faster than before. That's a genuine advance for archaeology, linguistics, and the study of the ancient Near East. Thousands of tablets that once demanded countless hours of painstaking work can now receive a useful first pass, allowing experts to spend more time on interpretation instead of routine translation. That's a powerful change all by itself. The Cuneiform Digital Library Initiative exists because this written heritage is enormous. New fragments continue to be documented, older collections continue to be digitized, and scholars continue comparing texts that were separated by centuries, kingdoms, and excavation sites. The electronic text corpus of Sumerian literature reflects the same idea. Understanding the ancient world isn't about finding one magical document. It's about carefully fitting together thousands of surviving pieces until a clearer picture begins to emerge. That process has never been quick. According to Archaeology magazine's reporting on the translation project, researchers see artificial intelligence as another tool that helps unlock this growing archive. It's a remarkably useful assistant, but it's still only one part of a much larger investigation. The computer can recognize patterns. Historians still have to explain what those patterns mean. Archaeologists still establish where a tablet came from. Linguists still debate difficult words, damaged passages, and competing interpretations. There's another reason that matters. Ancient civilizations rarely left behind neat, complete records. One tablet might preserve only half a conversation. Another could survive as a handful of broken fragments found decades apart in different museum collections. According to the Cuneiform Digital Library Initiative, scholars are still identifying, cataloging, and connecting pieces that belong together. Every new match has the potential to clarify an older translation or challenge an accepted reading. That means our understanding of the ancient world isn't frozen in time. It continues to improve as new evidence is documented, older collections are digitized, and specialists revisit texts with better tools than they had before. Some of those debates may never disappear completely, That's worth remembering the next time a dramatic headline claims an ancient mystery has finally been solved. The oldest civilizations rarely speak with one voice. Their stories survive in broken tablets, copied manuscripts, damaged inscriptions, and texts written for completely different purposes. Turning that complexity into one confident sentence might create an entertaining video, but it rarely reflects how history is actually reconstructed. Think about everything we've uncovered together. The real discovery wasn't a hidden code proving a forgotten theory about human races. It was watching how a legitimate scientific achievement gradually transformed into something the original research never claimed. Somewhere between the clay tablet and the viral thumbnail, certainty replaced caution, and possibility became supposed proof. Maybe that's the most surprising part of this entire story. Ancient history doesn't become misleading because the tablets change. It becomes misleading when the distance between the source and the audience is filled with assumptions, exaggeration, and stories that sound better than the evidence supporting them. The real breakthrough wasn't a hidden code about human races. It was a tool that helped scholars read one of history's greatest archives faster, while leaving the hardest questions to human expertise. So how many other viral discoveries grow larger than the evidence behind them?